Unit 3, Lesson 10. In this portion of the unit, we'll be talking about how you would find the center of rotation. So if you observe on the right, there's an equilateral triangle, ABC, where all three lines of symmetry intersect, which we constructed these lines of symmetry in practice number 9. We know that the line of symmetry is the perpendicular bisector of each side. So where all those perpendicular bisectors or lines of symmetry intersect, that is our center of rotational symmetry. So those three lines intersect at O. So O is the fixed point. Remember, a fixed point does not move, about which that equilateral triangle would be rotated onto itself. And recall that the number of lines of symmetry of a regular polygon equals the number of sides that it has. So since this is a three-sided equilateral figure, it will have three lines of symmetry. So to find the center of rotation, all we need to do is find the intersection of the lines of symmetry. So for example number 2, we're going to draw all the lines of symmetry. I'm going to note before I even do that this is a square. So there should be 4 lines of symmetry, because it's a square, and a square is a regular polygon. So I know that the diagonal, that's pretty shaky here. Let's try that again. That's better, is a line of symmetry. The other diagonal is a line of symmetry. We have a vertical line. That's pretty bad too, so let's actually put a line in here. There we go. It's a little better. There's a line of symmetry. There's another line of symmetry. So where all of those lines intersect, that is our center of rotation, which they said to label E. So what kind of symmetries are there? We have linear symmetry or line symmetry. And we have rotational symmetry. What is the order? Okay, we know that since this is a regular polygon, the order equals the number of sides that it has, so the order is 4. Okay, there are 4 rotations that will take this figure onto itself. So 360 divided by 4, that's 90, so the minimum angle of rotational symmetry is 90 degrees, and it says to list all. So we're going to take multiples of 90. 90, 180, 270, and a rotation 360. The identity will bring it back to itself. So again, 1, 2, 3, 4. The number of angles of rotations that carry on to itself should match the order number that you have. So I have 4 angles here. That will map the figure onto itself, and the order of the figure is 4. So you have an example below for you to try on your own for class tomorrow.